A very good morning to all of you. I cordially welcome you all for the Engineering Thermodynamics course. So for today's is the 16th classroom discussion topic. So previously we completed the first law of thermodynamics in the CDT 15. Now in the 16th classroom discussion topic, now we are entering into the second law of thermodynamics. So the topics which are to be covered in the today's discussion is state Kelvin-Planck statement, Clausius statement, equivalence of Kelvin-Planck and Clausius statements. So what is the motivation? So it is very, very important to know that how second law of thermodynamics is defined in the form of Kelvin-Planck statement, Clausius statement, and normally these are seems to be different, but these are same. So that we have to prove, that is the equivalence of Kelvin-Planck and Clausius statement, that is nothing but if we violate one statement, automatically it will violate another statement. So that is the violation of one statement leads to another statement. So the outcome of this lecture is, after completion of the lecture, so you should be able to state Kelvin-Planck statement as well as the Clausius statements. And the second outcome is you have to prove the equivalence of Kelvin-Planck and Clausius statements. So here the Kelvin-Planck statement, that is the limitations of the first law of thermodynamics, just we have to recapture. So there are two important limitations are there for the first law of thermodynamics. The first one is it is not giving us any information about the direction of the heat transfer. And the second one is it will not give us any information about whether a process is feasible or not. So these two limitations will be overcome by using the second law of thermodynamics in the form of Kelvin-Planck statement as well as the Clausius statement. So let us see first of all the Kelvin-Planck statement. So the Kelvin-Planck statement says that it is impossible for any heat engine that operates on a cycle to receive heat from a single reservoir and produce a net amount of the work. Or in other fashion, no heat engine can have 100% efficiency. So now that is whether a particular process is feasible or not. So that is, it is feasible only whenever the heat engine is operating with minimum two thermal energy reservoirs like source and sink. So that is in the second case. So first case is not possible. That is, here the heat engine is operating with only the single energy reservoir, that is the source. There is no sink. So when there is no sink is nothing but whatever the amount of heat is given to the heat engine. So the entire amount of the heat is converted into the work. So W is equivalent to Q1. So efficiency will be equivalent to work done by the heat supplied. So work is W. Q1 is also W. So efficiency will be equivalent to 100%. So that is, it is violation. It is violation of the second law of thermodynamics. That's why here I have written no heat engine can have 100% efficiency. So that is, whenever it is having 100% efficiency, it is the PMM2. That is a perpetual motion machine of second kind. So that is, it is impossible. So that is a limitation. So that is, here you can see very, very comfortably, that is a heat engine. It is a work producing device. Heat engine is a work producing device. So under what circumstances the heat engine will produce the work? So here it is the high thermal energy reservoir, that is the hot reservoir, which is known as the source, which is available at the temperature of TH, that is the temperature of the hot body. And another one is the another thermal energy reservoir. It is the cold reservoir, which is also known as the sink. It is the source and it is the sink. The sink is maintained at TC, that is the temperature of the cold body. So always heat engine will receive some amount of the heat, that is QH, and always there should be some amount of the heat rejection to the cold device. So heat rejection should be done by the heat engine to the surrounding atmosphere or to the sink. So that is, the heat rejected by the heat engine is equivalent to QC and the work produced is equivalent to W, and work is always the difference between these two heat transfer magnitudes, that is the QH minus QC. That is, how can you estimate the work which is produced by the heat engine is nothing but W is equivalent to QH minus QC. So that is, the Kelvin-Planck statement says that we can never have the 100% efficiency from the heat engine. So the heat engine will work with minimum two thermal energy reservoirs, that is the source and sink, with only one thermal energy reservoir, it will not function. So that is the statement which is given by the Kelvin-Planck statement. Next one, which is known as the Clausius statement. So the Clausius statement is basically the giving the information about the direction of the heat transfer, because one of the limitations of the first law is it is not at all giving any information about the direction of the heat transfer. So that limitation is overcome by using this Clausius statement. So the Clausius statement says that heat always flows from the higher temperature body to lower temperature body, and the heat will travel from the lower temperature body to the higher temperature body with some amount of the work input. So without any work input, heat cannot transfer on its own from the lower temperature body to the higher temperature body. So that is here, just you can see, so heat is traveling from the lower temperature body to the higher temperature body. So it is absolutely not possible. So that's why it is not possible. It is violating the second law of thermodynamics. So here, always the heat can be transferred from high temperature body to lower temperature body, but not from lower temperature body to higher temperature body without any input. So it is impossible, and the second one is possible. That is, here you can see, whenever we are giving some amount of the work input, so heat is transferring from the lower temperature body to higher temperature body. So that is the Clausius statement. So now the second important outcome of the lecture is, so that is, it seems to be different. That is, whenever you are studying the Kelvin-Planck statement and the Clausius statement, both seems to be different, but both are normally same. So that's why we can call it as the equivalence. So that is, the violation of the Kelvin-Planck statement leads to violation of the Clausius statement. Violation of the Clausius statement leads to violation of the Kelvin-Planck statement. So that's why we can prove that. So equivalence of the Kelvin-Planck and the Clausius statements. So here you can see the heat is transferring from the lower temperature body to the higher temperature body. Is it possible? No. So it is not at all possible. It is violating the second law of thermodynamics. So it is violating which statement now? It is violating the Clausius statement, because the Clausius statement says that heat always travels from the higher temperature body to lower temperature body. So it cannot travel on its own from the lower temperature body to the higher temperature body. So this is not possible. It is leading to violation of the Clausius statement. Let us say that it is not possible. Now, this particular heat pump is driving the heat engine. This particular heat pump is driving the heat engine. So this is nothing but, so this heat engine is now operating with these two thermal energy reservoirs, that is the QH and QC, and you know that the heat engine purpose is to produce some amount of the work output. Now the combination of this particular, the consolidated figure here is, so because this is not at all possible, so this is not at all possible to supply the heat from the lower temperature body to the higher temperature body. So now the combined effect isn't possible. That is, the combined effect says that the heat engine is producing some amount of the work with only the single thermal energy reservoir. So that is, there is no need of the sink. So there is no need of the sink means it is violating the Clausius, that is the Kelvin-Planck statement. So that's why here the violation of the Clausius statement is leading to the violation of the Kelvin-Planck statement. So that's why we can say that both are equivalent with each other. Similarly, we can say the violation of the Kelvin-Planck statement is leading to the violation of the Clausius statements, because in the either directions or in the vice versa. So here you can see the heat engine is producing some amount of the work by taking only some amount of the heat input. So there is no heat rejection. So there is 100% efficiency. So it is not at all possible. So it is violating the second law of thermodynamics and it is violating the Kelvin-Planck statement. Let us say that the work which is produced by the heat engine, which is used to drive this particular one. So here also it is taken from the lower temperature body to the higher temperature body. The resultant effect is the heat pump. So here the heat pump, without any work input, the heat is traveling from the lower temperature body to higher temperature body. So it is violating the Clausius statement. So now you can see the violation of the Kelvin-Planck statement is leading to violation of Clausius statements. So that is, so though the statements are basically different, but one violation is basically leading to the another violation. So that's why we can say that the both statements are equivalent with each other. So it is the important statements which are given by the second law of thermodynamics, and the limitations of first law are overcome by using these two different statements of the second law of thermodynamics. I hope you understand this particular lecture about the second law of thermodynamics, and let us meet once again in the next class. Thank you for attending and listening this lecture. Thank you.